Asbury and Tejon Park, a new vision for recreation and detention. Presented to you by team members, Blake Russo-Nixon, City and County of Denver, Dottie Wastewater, Sensore Eads, City and County of Denver, Parks and Recreation, Don Jacobs, Ingenuity Engineering Solutions, and Joshua Eldridge, Great Ecology. Sensore, please take it away with some of the planning information for the park.
So Asbury Tejon Park is located in the southwest part of Denver near Ruby Hill Park. It's in the College View neighborhood and is bounded by Evans Avenue to the south and Federal Boulevard to the east. The park, as you can see, is primarily dominated by bluegrass turf, and the utilities and the concrete channel, along with the side slopes, really reduced opportunities for recreation. Along with that, the playground was very old and tired, and we really just thought that this could use an upgrade. What really prompted the revisioning of this park was a site visit with some park planners in 2015. And we saw this outlet structure and really started to question the safety and really the concern for how the site was functioning, not only as a park, but also for the detention. So in 2015, we were able to partner with the Office of Green Infrastructure to apply for a grant through our Denver Department of Public Health and Environment to really evaluate different options for retrofitting this park. And what really made this partnership successful was that we partnered very early in the planning process. So we were able to initially understand what each department's goals were from a water quality and stormwater detention standpoint, but also what did we need to accomplish within the park setting. Then we did the technical analysis, and that really allowed us to understand the opportunities and constraints that would help meet each other's goals. And then we had a very robust community outreach process that helped ultimately develop our concept plan. So the community planning process was, again, very vital to to the design and planning process. It took place over 12 months, and we did 3 formal public meetings where we met in the evening and reviewed the goals and different concept plans, different amenities that could or couldn't be included in the park design. And then we had one event in the park. And that was really important as well because it provided an opportunity to educate the community on what was the function of this site first and foremost. It protected their community from flooding events, but also what are some of the other city goals? Improving water quality, enhancing and increasing our biodiversity within our park system, and reducing irrigation. And that ultimately led to a really balanced design that helped meet everyone's goals and the community's vision. So this rendering showcases what was ultimately the basis for design as we progressed. And you can see there's more flexible space for recreation, and we were able to reduce some of that turf landscape and reduce our irrigation consumption and provide a more balanced, native, and active recreational space for this community. And in 2018, Greater and Greener held their conference in Denver, and Toro awarded Denver Parks and the design team with an Innovative Design Award. And with that award, we received a $50,000 grant to design and install interpretive signage that will be installed later this year. Now I'll turn it over to Josh Eldridge to go into a little more detail of the design process.
Thank you, Sensei. Great Ecology was brought into this project in the spring of 2016, and we were presented with this aerial image of the existing park conditions and a hand-drawn sketch of the vision of what we wanted this park to be. Ultimately, we were able to create a park that really did strike the balance between all of the competing objectives that were lined out from the process in coordination with the Office of Green Infrastructure and Denver Parks and Recreation. So we were able to look at both what the water quality improvement requirement would be, including the detention times that would be necessary to help meet the water quality capture volumes as outlined in the Stormwater Master Plan. We also wanted to create more usable recreation areas for the park and the community that accesses this space, while connecting to nature in a way that was meaningful and informational, while also protecting the existing trees for a park that had been established over 50 years ago. We were also looking to lower maintenance requirements and make the park safer. There were issues with lighting and access around how the park was being currently used, and we want to try and make sure that we utilized crime prevention through environmental design principles to make sure that community users felt safe in this new space. So in order to balance all of those competing objectives, which oftentimes are very complicated in and of themselves, we looked at how we could realign the channel, remove the concrete pan from the middle of the park to improve the play area. We concentrated the detention basin, detention capacity to the north pond that allowed more of the park and program space to be concentrated in the south pond. We looked at vegetating the wetland channel, utilizing wetland sod to help expedite the stabilization and plant growth within that wetland channel. We converted a lot of the turf grass that surrounded the basins into native mixes, which also allowed us to reduce the irrigation water usage for those areas. And we did that with a diverse native seed mix that really leveraged the understanding of the site soils with the objectives of what this park was. We were able to expand the playground and move it away from the housing complex that borders the western side of this park to really make it feel like it was a playground for the larger community and not just the one section of housing that was closest to the park. We also defined the turf grass areas and removed both utilities as well as that concrete pan that defined the initial concrete trickle channel. We also utilized nature-based play features to increase the number of play features that the community could utilize. Blake will touch on some of those nature-based features later, but that was really an important amenity that allows kids to have that connection to nature that traditional playground areas don't always afford. So we started with this image, and we were able to create a design that really did balance a lot of different competing objectives through regular communication and collaboration with a diverse set of disciplines and expertise. We were able to really create a vision that allows this community to be proud of the space that they have, as well as benefit the city's objectives of improved water quality throughout the city. Now, Don will talk a little bit more specifically about some of the engineering challenges that we had for this project.
Yeah, as Josh and Sinsure have been saying, the goals on this project really are kind of conflicting with each other, and it's a balancing act to try to get everything to come together. So some of the parameters that we were dealing with, the engineering parameters we were dealing with on this park, is the fact that the park sits on an old natural drainage way. I don't know how well you could see this drainage map on the screen, but the blue tributary area on the north drains directly through the park. The main thalweg runs through the park. We call that the direct basin. But the yellow basin on the south really is tributary to Evans Avenue, but there is a diversion pipe. It's a 48-inch pipe that diverts low flows into the park. So we call that the diverted basin. And those two are kind of important as far as what we want to design for in the design parameters. I'd say the north tributary is 133 acres. The south is 143. So that's about how much drainage area we're handling here. So as we were saying, everyone wants more. We're trying to do a lot of things in this fairly small space. And, if you're not careful, you can end up treating all the water quality that you want, meet all your goals, but you have no recreational opportunities. So trying to balance that, I think there were some hard parameters that we had to hit. the park had already served in a stormwater detention capacity, and it had 11 acre-feet of volume. I felt like we had to maintain that. If we reduced that volume by any means, it would end up creating flooding issues downstream. The receiving drainage system below this park is undersized, and any reduction in volume here would negatively affect flooding downstream. So that was kind of a hard number. Areas that we really kind of tried to balance the design between play field and water quality volume was kind of one of the main ways to balance this. If we treated both of those tributary basins, our goal would be 4.7 acre-feet of water quality capture volume. Having laid out the kind of the vision of the park, trying to balance everything, we ended up closer to 2.1 acre-feet of water quality volume. And that fully serves that northern direct tributary basin. So while we weren't able to treat both in this limited space, I think we were able to treat the direct basin, which is, I think, good kind of compromise in balancing this whole system. So, another part of the balancing act is drain time. A lot of times a detention pond, it may be behind an old warehouse building or something, not out in an open park like this with a lot of people recreating. So we want to kind of balance that. The longer that we hold water, probably the better water quality treatment we get, but we don't want it sitting there for extended amount of times in this park setting. I like this picture here on the left. That's the original outlet structure in the old park. And as you can see, somebody just ripped off the front outlet structure, probably an orifice plate or something. We're not really sure when that happened, but I think it points to the fact that, in a park setting like this, when water doesn't immediately drain out, people can view it as a problem. So we kind of wanted to balance that drain time. And it's really, for me, one of the lessons learned on this project, and it has two parts. One is we have direct base flow running through the pond. And I'll just say, I learned that you really want to try to anticipate what that flow rate is. Here, every time I went out and looked at it before the project, it hardly seemed like there's any base flow at all. But after construction started and after it was completed, we're seeing quite a bit of base flow going through, and our orifice structure was not sized to handle that. So we had a lot of ponding water at the beginning that we didn't want. So, and also we had elliptical slot weirs is what we're using here that we thought would be a little better self-cleaning than they were without using a trash rack. So those were two changes that we did kind of towards the end of construction. And next, Blake will talk about some of the challenges, including those two fixes that we had to do. Blake will talk about some of the challenges that he found during construction.
Thank you for that, Don. Asbury and Tejon Park required a path wide and competent enough to support City and County of Denver maintenance vehicles. These vehicles were to access both outlet structures and weigh up to 70,000 pounds. In order to reduce imperviousness within the park, the project team decided to utilize void-filled riprap as a path material. The proposed design was 2 feet of VFR over Tensor TX 160 geogrid. Unfortunately, the expansive soils and the mucky conditions did not allow for an approvable proof roll. After some time and thought and consultation with geotechnical firm, the VFR depth was doubled and we upgraded the geotextile. This application still failed to support heavy on-site construction equipment. The solution was a more conventional approach, a 6-foot depth of VH boulders pounded on top of each other without any additional soil filling the voids. Then the VH riprap was top dressed with some VL riprap to interlock and provide a smoothable driving surface for City and County of Denver vac machines. Next, we'll talk a little bit about nature play. Nature play leaves a sense of being in the wilderness while in the city and is becoming more and more popular in Denver parks. Utilizing project collaboration with Parks and Rec and with forestry, the contractor was able to pick up downed trees from a nearby forestry yard and chainsaw them into pieces of art. Some of the specific park features included log stairs, a ghost grove, and a log flume. These features not only are aesthetically pleasing to the public, but are incredibly customizable, leaving each park with its own artist interpretation. There are some challenges with these play features, including wood being less forgiving to work with. Capturing desirable surface slopes was a challenge, and increased coordination between the project team and contractor. But in the end, the extra work is worth the custom product that makes each park unique in the city and county of Denver. Some of the issues with tying in a park's old irrigation system and a park's new irrigation system include unexpected leaks, non-compatible wiring, and faulty components. Each time the project team ran into an issue with the old system, progress was delayed. Ultimately, there were unexpected costs added to the project as the contractor ended up performing work outside of their original scope. Other issues arose from the proximity of the irrigation alignments to mature trees on site. Forestry specification prohibited excavators in tree protection zones. Air spading was not allowed due to potential of asbestos on site. And hand digging was also not always possible as root systems were too dense to insert pipes through. In the end, the contractor performed much more hand digging than anticipated. Directional boring increased installation costs significantly, and additional time was added to the contract. A more upfront, collaborative approach in retrospect, involving all stakeholders during design, may have been able to flush out some of these potential issues, making the scope of work more transparent to the bidders and ultimately more cost-effective for the city. As construction wrapped up and the seed and sod began to take root, the project team installed the elliptical slot weirs on both the outlet structures. After the first large storm event, it was apparent that the weirs were not allowing for optimal detention drain times. As trash and debris filled the basin from the commercial neighborhood, the weirs clogged. Water levels rose for long periods of time and created anaerobic conditions which killed off the vegetation in the entire bottom of the detention basin. So the solution was a collaboration between the project design team, CCD Green Infrastructure, and CCD Wastewater Operations. Wastewater Operations quickly fabricated a perforated well screen with a large enough surface area to avoid being easily clogged by trash and debris. Then 2 4-inch orifices were cut into the weir plates, calibrating the weirs with the base flow and the water quality parameters necessary. Lastly, our great landscape architect was brought on board as adaptive management partner to study the basin, analyze the soil conditions, and recommend site-specific vegetation for long-term success. So some of the final thoughts: communication and compromise. They are key. Community buy-in is very important in projects like this. Balancing stormwater and recreation, well, it takes thoughtful approaches and a lot of patience. And collaboration, it doesn't end just when construction ends. So I appreciate everybody listening to the presentation, and it's been a pleasure projecting some of the project history from planning, design, and construction of Asbury and Tejon Park. And now we'll take a few minutes for questions. Thank you very much.